Hi, I'm Benny Johnson, and this is my Module 1 demonstration. I wanted to start with a really quick overview of how the code is set up so you better understand what's happening. I am using the built-in LED for this, although you could change pretty quickly from LED built-in to any other LED. There are some utility functions that I wrote for things like debug printing, writing the LED, so this is where you would change it if you wanted to use a different LED, and this safe serial read function, which provides a little more security and control over how data is read in from the buffer, so that users have less ability to damage the program. This types header just contains a couple of useful types I had, an enumeration for that safe reading header, as well as a simple struct that represents a Morse code character as Morse code, so that we can easily scale it to different behavior. The Morse code header is pretty long. The main pieces here is it defines specifically how much each of these spaces, dots, and dashes are in terms of just a general unit. And then this unit length, milliseconds, determines how long each of those are. So if we want each individual unit of time to take a little bit longer, if we just want the whole Morse code to move slower, you can modify this unit length ms constant, and that will affect that. Everything else here is constant and unchanging, and you can keep those the same regardless of how fast or slow you want it to blink. Defining these constants, I then defined for each character what it was in dots and dashes. Same for the numbers. And then there are some conversion functions here that can take you from a character to Morse code with a case conversion. It has a case where it signifies that a character is not handled, and we can avoid that then and not try to display Morse code for it. And then we also have this means to convert individual dots or dashes back into an ASCII representation so that we can print it out to the terminal, as you'll see in a moment. Then finally, we have this display string function, which effectively implements the program logic of stepping through our Morse code structure and printing it out to the console. Then all of that goes back to main here. Main just waits for the serial to be open. It clears out the buffer to avoid things getting a little too messy. And then it waits and accepts user input or handles this control Z signal. So here we can see what a user is presented with if they're on the serial console of this application. So you can send it a string with mixed lowercase, uppercase spaces. You can include special symbols, though they won't be converted to Morse code, they'll just be ignored. And then you can send this along. It will display it in Morse code. Under the hood, this is all represented as dots and dashes and scaled to the actual time. So while it's doing this, it's also blinking the LED at whatever rate is being displayed here. But this way you can look at it in a text format and more easily compare it to the Morse code guide that came with the project. And from there, you can continue to input strings if you want to, like hello here. And note that I've sped up the rate here more than I would if I was showing it to you on the LED. And once you're done and you want it to stop accepting input, you can send it a control Z and it will put the Arduino to sleep. So at this point, I'm typing on my keyboard, no input is going to it. It delays for a very long time and loops that indefinitely. So if you want to start talking to it again, you need to pull power or upload a new image at this point. So to show that this transfers to the Arduino, here's the phrase hello world 123, and you can see here again it writes out the Morse code as it's written, and we can watch that same thing blink on the Arduino.